the stage.
Thank you for the introduction. So, I've been in this industry for quite a few years, and one of the things that I wanted to really get across today was, especially semiconductor, right? Semiconductor is not new to India. We play in every part of semiconductor except for the manufacturing piece of it. And one of my famous quotes is, there's an Indian in every chip. Either they're in the IP, for sure. They're in the EDA tools. If you look at all the EDA tools of Cadence and Synopsys, is dominated by the Indian engineering. And then if you look at the equipment making, right? So you look at Applied Materials, which is one of the largest semiconductor equipment maker. It's full of Indians again. And you've got Chang research. Again, same thing. If you go to TSMC, you'll see a lot of Indians as well. So we should be very proud of ourselves that we are in the semiconductor domain. Although we can't call ourselves, as an Indian company, right? There's not much has been done there. And I think this is an opportunity for us to build that ecosystem and play a key role. And the reason why I say that is semiconductor is poised to double in the next 8 to 10 years, right? As all of you know. Now, who's going to do that? So I'm from TI, and I started TI in the 80s. And when TI started, everything was vertical. Right? They had to have their own fabs, packaging houses, even their own equipment, right? So in order for them to be in that industry, things have changed a lot over the last 70 years or so, where pieces of this has become specialized stuff that they do. And also, there's a lot of consolidation that has happened. Now you see all these large gigafactories, if you may, right? TSMC, AAC, and so on, right? They're very, very large, multi-billion-dollar, tens and 20, 30, 40 billion-dollar type of companies. So it has been also consolidated in such a way that barrier to entry is very high. So whenever people talk about semiconductor, there is a myth that it's very, very hard to go in. But there are ways that I will speak about today. How do you democratize semiconductor, especially if India is a very vibrant democracy in that sense, right? So culturally we think differently. So how do we create businesses out of that cultural strength that we have? A semiconductor company today in India, we would do it very differently from how the semiconductor industry has evolved, right? Because when I was in TI in the 80s, this is how it was, as I explained to you. So now, should we ape that and try to do similar things in order for us to get a start on it? Or should we look at a clean slate? We can set the direction and how we go about. My take is this. If we have to do it, we will do it differently. We have to do it differently because we are already in 2025. Obviously, there's a huge foundation that has been set up. How do we use those strengths? And being a new player, it actually helps that you don't have the weight of the incumbency. So, for example, right? So TI, for example, and I'm from TI, so I have a lot of ideas about how TI typically thinks and moves. They have a huge manufacturing base. The way they create products, the way they bring out products, has a very kind of a legacy approach. Now we have a lot of other tools that we could use that it do not have to follow those kind of processes. So there is a new way of doing things. So we should set our own ideas on how we're going to go about creating a roadmap of products for ourselves. I'm talking about a product company, right? By the way, I had my own services company, which India is very famous for. We always try to do services for somebody else. And finally, I decided that we should control our own destiny and create our own products. So, as I mentioned to you, the idea is to bring everything together, right? So the SoC, right, system on a chip, the idea was you bring all the functions that are available or need to be there into one chip. So you have this massive chip, which has got all these different functions. They may be even using different processes and so on, but kind of try to compromise and bring it into one SoC. Now that worked for a while. I'll give you an example. See, you all know about Qualcomm, right? Qualcomm makes some of these modems and a processor and so on, right? The telecom and the cell phone market. They try to bring, because they want to sell more functions, more chips, right? So they try to bring all of them into one chip. And what they created was a massive chip. Now the cost was obviously very high because, as you know, as the chip becomes bigger and bigger, the yield goes down, right? Because you look at a wafer, right? As the chip becomes bigger and bigger, you are covering more space, and there's random defect in the process, right? So the yields will certainly be lower for a smaller versus a smaller chip versus a larger chip. So the cost was higher, and their thinking was now we could sell this and take out all of our competition. They have different functions. But actually from a customer viewpoint, they did not look at it positively. They looked at it, number one, they didn't want to get dominated by one company, right? And the second thing was, a lot of innovation happens on the periphery, right? How do you manage the power? How do you manage the noise levels or data speeds? So there was a lot of things that they could do in the periphery at the interconnect level, which the customer wanted to have an option to deal with. There are many companies which specialize in certain things, right? Let's say a SerDes IP may have, a company may do a lot better than the chip guy that you're doing. So it didn't actually work out from a business standpoint as well. So we have the last few years, right, the concept about splitting it up into what we call chiplets, and so that each chiplet will have its optimized process. Say for example, the computing needs to happen on the 2 nanometer or 3 nanometer, and the PMIC, which is the power management, can probably handle with the 40 nanometer or 65 nanometer. And then you may have some analog chips which can do 130 or 180 or so, right? So all of that you can now integrate it at a chiplet level or at what we call at a package level. So now you optimize it. Now that needed a lot of standard creation and so on. So I think it's happening. So we in India, when we approach this, when we have an aspiration to make our own microprocessor, this is the kind of approach I believe, right, we should take. This is another area that I think India has a unique advantage because we don't have legacy, right? So what we could do is when we work with our customers, for example, my company IVP, we are into power. We want to give them modules and subsystems that can be easily integrated into the final product. So this is an advantage because of our scalable resource we have, right? We could have more staff working on the field application and customer interface. With some of these major companies may not be willing or would not have the way of doing that. Because if you look at Indian customers, we are still not tier 1 in the semiconductor. Frugal engineering. This is by nature, right? By nature we are frugal, right? We're very, very reluctant to give money away, right? We always want to keep it. And whatever, our rupee stretches a lot more. And these days with the exchange rate, it's actually stretching even more. So frugal engineering doesn't mean just about money and money itself, right? I mean, we know how to use money, and we always, programmed in this way, right? Since we were kids, right? But I think, it also means zero waste. So zero waste means, right from the start, right? When you create a product, you're already thinking about how do I not waste anything, whether it's a resource, the kind of material we use, the kind of material we pick up, how we do the supply chain. So it covers a lot of aspects of this. And one of the key things that we could probably think about, which is the strength of India, is the human resource, right? We have a scalable human resource. So think about this. Say, instead of everybody trying to hire their own people and build, all the different functions, right? Let us say, for design or marketing or prototyping, so we have, a whole bunch of people working in a company, let's say. And let's say there are two companies, company A and company B, and they may be competing in certain areas. But just think about the concept where if you're willing to collaborate, because the expertise may not exist in one company which is required by the other company. So if you think about it, right, if you're able to collaborate, the word is collaborate, right? If you are able to collaborate and share some of these resources, your success, because one is, you could reduce some of your costs, because when the guy has some time, and typically you're not working, even though we say we work 60-70 hours a week, how much of it is productive and so on is questionable. So even if, let's say, an expert in your organization is able to help out another organization maybe a few hours a week or so, right? You make the other guy as well successful. So now you have created two companies, and you just think about it at a very, very macro level, the kind of success you can have. Because one of the problems I see is, the startups in India is, you need expertise in many areas, right, in order to make a chip. One of the reasons why we are not that successful in chip making versus producing chip product companies versus the software. Right? Software, you have everything under control. Right? You have, let's say, 100 people working on a particular software. Everything is under control within your own management. But making a chip, other than you do the design, using some of the tools, you have to work with fab guys, the packaging guys, the test guys, you actually need to put it in a physical system somewhere. Besides working on the technical side of it, you also need to understand the business aspect of it. So you have to make a chip, you have to touch so many different companies and so many different people. And that is one of the weakness we have, right? Working as a team, working as a collaborators together. We're not so programmed to do it. We are very much individual people. That's how, when I was growing up as well, right? If I tell my grandfather that, my classmate actually got better marks than me, I'm so proud of him, he would say, why didn't you get the marks? I mean, this is a kind of attitude. And my kids in the US, when they come home, and they are very proud of the neighbor's kid because he did really well. And I got to hold myself and say, yeah, good for them. Because still when they're young, right, they work on teams. They're very happy to work with teams and recognize the strengths and weakness of different people. Because when you put all the strengths together, that's where you create a product. You have to work with multiple people. You need to have the mindset that you could do that. Otherwise, it is not a one-man show. So frugal engineering covers sharing of resource. I will go a little bit more detail into manufacturing. I'm a big believer that in the last 50 years or so, we have created all these mega factories which have consolidated and become, whenever you talk about a semiconductor fab, you always talk about 10 billion. Right? I mean, the number of zeros in billion, I can't remember how many zeros are there. I mean, it's just crazy. And I think this has been created by the existing players so that the new guys with the kind of frugal thinking will not be able to get in. And we bring that Kool-Aid in this. And we believe that. But I do believe that when we started, for example, when I was in TI, we had our own fab. The fab was meant for running the product. We don't build a fab to figure out how to fill the capacity. So it was the product which was driving the fab, not the fab driving the product. Today, I think we have got it upside down. Right? The fab determines what product that you can run, and how they engage with you. They want to fill up the fab, right? So if you think about it, the fab, right? What is the ideal fab? Right? If you are running a fab, you want to run one product forever, right? So you don't want innovation actually to happen. You want this PDK, and everybody follow that PDK. You don't want people to tune the process to optimize your work. You want customer who is big, right? Who can take all the capacity. You don't want multiple guys, startup guys coming and disturbing you for a few wafers here and there, right? And you want to make the maximum profit. So what you do is you need to sell at a higher price. So you don't want to evolve low-cost processes because you'll have to make a lot more wafers in order to get that kind of revenue. So if you look at it from and businesses are driving the innovation in this in this industry because it's actually I look at it as very similar to a mafia kind of approach because you have a few companies controlling the semiconductor industry, right? A few, you can name it, right? You've got TSMC, you've got NVIDIA, Intel was one of them, now kind of restructuring. You got AMD, so they dominate, right? They've got Micron, and, Samsung, and the memory, and so forth. So you have about 10 companies that rule the world. Can you imagine? It is even worse than oil companies. So the behavior they have will be quite different. Nothing wrong with it, but because that's how they're structured. My point is, we in India coming in do not have to follow that structure. We can disrupt that structure and create our own methodologies of how we create our own company. There's the talk about on the frugal engineering. So it's not just about money, it's how you think and how you do stuff. How do you have inclusiveness, right? So instead of building these mega fabs, maybe we should be building where it makes sense for these fabs and in the localize it. Right? If you say a $10 billion investment in one small city or town in somewhere in India, can you imagine, right? The amount of resource needed to feed this fab, right? It's going to take a lot of water, toxic gases, and this and that, right? So kind of siphon off a lot of the resource from that area. Versus if you're building smaller fabs, right, all over the place, and it becomes manageable and becomes managed by the local people over there, right? So there's a lot more inclusiveness that happens. I can guarantee you that when we sell our chips, we'll work 100% of the time. Okay, this just to show you a little bit of a concept, right? This is something that I believe in. They take it at a very high level as a concept, but we could work on this. So what we have is, we built all these fabs, and the kind of theory that went behind was, build this huge fab so that we can pack more transistors right? So if you look at probably NVIDIA is probably the leader in packing the most number of transistors in a real estate, right? So it was more based on transistors and logic and memory kind of fabs, right? So they were optimized for that. And you try to run, the newer technology on this, right? Obviously, it's not optimized for that. So the one on my left is what we're talking about, where a lot more things have happened, right? In terms of sensors, MEMS, some analog stuff that building blocks for this, right? This is where the chiplet comes into play. This is where subsystem comes into place, because you cannot just have a processor, right? There's a lot more other things that goes around it. So one of the things is, what we call beyond compute, right? So you have a computing engine, right, optimized for a certain thing, but you also have a lot more other things that needs to work with it, and you don't need to run that on this mega fabs and create this structure, right? So you could actually create distributed manufacturing for these kind of products. So it used to be our fundamental of logic, right? It was all transistors, and when I first started in PI, we used to do a lot of spice modeling, how to make a better transistor, and then you kind of populated the layout and so on. Now it's a lot different, where each system, each subsystem or the element, right, for sensing has to be designed locally, understanding what it's going to take to do it, versus this massive digital way of creating a product. Right? So it's a lot more understanding of the end application. How are you going to get that information? How are you going to convert it, and so on. So I think this is where for India, especially again with the scalability we have, we can create millions of products in this, because we have the kind of engineering. The one thing you need a lot of engineers to do the kind of work that I'm talking about on the left side. So it becomes a lot more interaction with the physical world, right? And I also believe that India throws all kind of problems, right? My sister is a doctor in the U.S. She studied here and she finished her medical school here. And then one of the things she always tells me is she's a better doctor in the U.S. because of the number of patients that she could see in India when she was here. So she would probably see 100 patients a day. So she had seen a lot more, right? So she saw many different kind of problems. Right? So we have a situation. At least we have kind of a test bed in India. You name it, we have all kind of problems, right? All kind of problems that the world really needs to solve. So we have a very good test bed in that sense, right? We can find issues that we need to go and figure out how to solve. So I believe that with this kind of engineering, where it is distributed and very targeted with the different kind of products, what we create will be true global solutions that the world needs. I would say the last 50, 70 years, right, where semiconductor has played a very big role is for the affluent, right? For the people who could afford it, right? So, when I worked in PI, National Semiconductor, and so on, when we define a product, the first thing is, my president or vice president will ask is, okay, what is the return on investment? Who's going to buy it? Is there an affordability for them to buy it? So the targeted people were more from an affordability standpoint, not really solving a problem. Solving the problem for the masses, right? Which I think is very important where we are today, right? With all the climate warming and all the other food security, water issues, and so forth. I think this is where India can take a leadership, because our thinking will be more about solving a problem. I'll give you another example. If let's say there is a problem, you give it to NVIDIA, and you give it to an Indian startup, they will come up with two different solutions, right? The NVIDIA, with all the power they have, will definitely come up with an expensive solution because they have to sell expensive solutions, right? So they will come up with the most sophisticated chip that needs to be used for this, and with the cooling for the power consumption and so on. Whereas, a startup in India with all the frugal engineering that they have to do it because there's lack of money and resources, they will come up probably maybe not as good as an NVIDIA in terms of solving the problem, but probably 80-90% good enough at a fraction of the cost. A fraction of a cost that people can actually use it in real life. So just the approach, right? Think about the approach. It's dominated by one material that, because of size and cost reduction, because the concept is always about how do you consolidate and reduce cost. Consolidate and reduce cost. This has been the kind of all our management experts talk about. And I think in practical real life, right, that's not how people think and how people work. So I believe that there's so much innovation that's going to happen on the material side. And when you go to the material side, right now, if you look at the wafer sizes that you're talking about, 8-inch and 12-inch, right? 12-inch is most prevalent. And so I always have this argument with these people about what kind of cost structure needs to be there. And I think that's a wrong question to ask. Because even if you have a 6-inch or even a 8-inch, which is smaller, the number of die you can pack in it will be less. But at the same time, by playing with the different materials, you would actually be able to create a better product. And let's say for power, for example, there is a lot of work that is being done on different kind of material to create high voltage products and all that. So I see a lot of students have come in. Good. Most of you, are you from Semiconductor or ECE or? Great. Good time to be in ECE, good time to take up Semiconductor. There's a lot of opportunities. Right? Just be flexible, and so there are opportunities in designing circuits, and that's not the only thing. Right? You all want to be designers, but I think material science is another area. Right? How do you change materials and change the how electrons flow and so forth, that's device physics. But then you get into more and more deeper, how do you create circuits? And so I'll conclude by telling you what are the opportunities for youngsters. So this concept that I talked to you about, you have this huge fabs, and now we're thinking about, at least I'm promoting this as an idea, how do you create more agile fabs with about less than $10 million type of investment versus the $1 billion investments. And I need to conclude. All right. So we have multiple systems. So this is another area, right? A lot of things about semiconductor has to be very reliable. Has to work for 25-30 years in a harsh environment. So there is a whole science and engineering that is devoted to testing and creating reliability. This is another area, right? If you like to do testing and do a lot of data analytics, this is an area, because invariably, right, we always assume that a chip should work forever. Right? So how do you create reliability and so on, right? So I think this is another area that young people can start thinking about. Another thing, we all heard about automotive. Automotive requires almost like a 0 defects per million or so, parts per million. And so what that means is, your chip that goes into, let us say, a million cars, right? You should not have even one defect, 0 defect, right? So think about it. So the kind of robustness we need to build both in the design as well as in the process. So there's lots and lots of exciting things that you can do in this area. So I'll quickly go through this. One of the problems we have in India especially is funding for startups. I think the government did an extremely good job about funding the manufacturing. The last fiscal year, there was a lot of money that went into fabs and packaging house and so on. And this year, I'm glad to say, because I work with AP as well, they are really, really encouraging startups. They're going to put a lot more money behind it. One of the schemes they talk about is the DLI, Design Link Incentive, and they've upped the amount of money that they are going to invest. And also, they are also encouraging private sector funding to come into this. And this is my aspirational goal, that when I told them, I said, look, they want to fund about 100 startups, right, which is an aspirational thing. Right? Hopefully, there are 100 companies that apply, or maybe 200, 300 people apply, so that 100 of them will get it. Now I said, hey, what is the objective of this DLI? Can we create solid Indian companies? So one of the aspirations was at least create about 5 companies which has got about $100 million revenue in 5 years. Right? That's a goal. Can we do that? And how do we fund them, right, in order to make them successful? Because a lot of funding requirements are there. And then at least 2 companies within all this gamut, within 10 years, to become the top 10. Right? Indian companies are top. So this is another aspirational goal. So I think we need to set our direction and the roadmap and go after these aspirations. So there's a lot of details in this. I'll skip some of this. These are some of the issues we have. There are startups that a bunch of designers, usually designers, come together and they create a startup. They're very excited about this. But there's a whole ecosystem that needs to support it, and they're not very familiar with it. So one of the things I call this is there's a valley of death, where we do a lot of design, but taking it to making a final product is a challenge. So most of them die at the design stage, become IP companies. So today, right? We really don't have something to say. We have our own chip company, right? Like a MediaTek or something. In a small country like Taiwan, I have my friend from Taiwan. There are so many startup, chip companies out of Taiwan. 100, 200, 300, $400 million, kind of revenues. Very, very good companies, great products. And then of course you've got MediaTek, which is a multi-billion-dollar type of company. A small country like Taiwan did it. Right? How did they do it? Because what they have is they have the experience on this side of it, on this side, right? We don't have that experience. We are very good at this, the design side. Now, as I mentioned to you earlier, right? You need the whole thing in order to create the product. And this is why I brought my Taiwan friend here, because we need to really, really align and build our businesses with these Taiwanese companies. They're there to support. And how do you work with them, right? In order to create more. So we need to cross the valley of death. One of the, these are all how we kind of channel all the resource from a funding, from IP standpoint, to enable these DLI companies to be successful. This is kind of, more of a, how do you do the funding, and how we are creating a very specific semiconductor fund to enable this, right? So I believe the government is actually doing a wonderful thing now in terms of promoting semiconductor. I think as young people, this is a very good opportunity for you to get into semiconductor. When I started in semiconductor 80s, it was this kind of a moment. There was an inflection point where a lot of the product, because transistors were getting commercialized and so on. So I think that another moment has come when India coming into this, where you're going to create millions of products. Okay, I'll stop here. I think, if there's any questions, please. Any questions?
So what I see from this is like anyone who wants to start entering into this semiconductor thing. So can we directly go ahead with manufacturing, or shall we start with testing? Then you develop your capability over a period of time, then start manufacturing. Design to already I think we have there. So what is the, can we take that same strategy to start with testing, then over a period of time increase your capability to manufacturing? Is it like that? Because some blog articles also says that some developed companies like Taiwan also over the, I'm not sure how much real data it is, because internet is sometimes full of randomness also.
Okay, I got your point.
Yes, yes.
So, we have to take baby steps, right? There's no question. We have to take baby steps, learn how to walk before we can, crawl before we walk, and then run, right? So the baby steps, like you mentioned, are the OSATs and the testing and so on. Those are baby steps, which can be done, not too complex, amount of investments. You can stretch the investments and so on. So that's the right thing to do, which we are doing. Right? The fabs are, as I said, right, we have created this myth about, we need to have a 3 nanometer, 4 nanometer, 28 nanometer. But I think, there's a lot of, technology out there which doesn't require that. Right? You could start with 130, 180 nanometer, which are easier to do. Right? There are people very competent that can come and set it up and have a first-time success. In 3 to 5 years kind of time, it's possible. And that's what you want to do. And what I'm proposing is, even this micro fab that I'm talking about is give the $10 million type of investments, $10 million type of investments in multiple locations, so that you create the awareness. You can play around with it. You can't build a logic, you can't build a memory, but you can build other things. So you get familiar with, tweaking and playing. So one of the issues that I see is, especially our education system, doesn't allow tinkering. Right? Doesn't allow tinkering. It's always like, just read this book and this is how it is. In real life, that's not how it works. You try to design a very, very simple analog chip or something, and you fab it, you come out, it will never work the way you thought it's supposed to. Right? So there is a lot of tinkering that needs to happen. One thing is, you must be bold enough to look at signals, look at how the product works, and not be worried about it's not just software. So the mindset also needs to change. Right? A lot of hard work and repetitive work actually you need to do, and then fine tune it. You should get the skill of seeing the signal rather than just some digital. So I think all those things are have to play together, but certainly we need manufacturing to be. DLI. Yeah, no components. So I really don't know what they really mean, but I believe components means anything that goes around the system. Right? It could be cables, could be displays, could be anything to do with probably electrical stuff that goes around a chip and so forth. Right? So all that needs to come together. That's what I think. So there are two schemes. One is called PLI, and one is called PLI. The PLI is more on the production link. So once you get into production, we are actually doing a lot of component manufacturing in India, right? The cable, PCBs, and so on. So that has got a different scheme. Right? So, it's a good question in the sense, all of this has to come together from an ecosystem standpoint, and there's so many opportunities in this. There's a lot of innovation that will happen. The PCB and the component side, assembly, and system testing, and so on. And the one that I call it the heart of electronic systems are the chips. And that has got a very specific interest. So I think if you want any specific things, please, I'll be around. Thank you.
Thank you, sir. That was a great session. We have a small memento for you. I'd like Mrs. Poonam Kapoor to hand over the memento to sir. Our next session is on IoT and AI simplifying sustainability for a better tomorrow by Mr. Ratina Sami.